Hey guys, this is your teacher, Mrs. Bloom. Our video note today it's on Unit 4.5, Example 2. So I came back to class and I saw a bunch of us wrote on the whiteboard about my division problem. How about this one right here? I guess I did this division problem incorrectly. You see this right here? So on the whiteboard that you guys had written, I wrote -6 divided by 3 is -3, which you guys all did that, which I appreciate. So this is -6 divided by 3, which is obviously not -3, but it's -2. So this right here should have been -2. Sorry about that. Anywho, today we are going to start with example 2. The direction is find a rational function that might have the given graph, okay? And we have done problems like these before with polynomials, but today we are going to write functions for, write equations for rational ones, okay? So a couple of things that you're going to need to know how to do is to identify all of the x-intercepts, y-intercepts, VAs, and so on and so on. So the first thing I'm going to write down is x-intercepts, okay? So do we have any, okay? If we do, where are they at? So x-intercept, the first one I can see is this location right here. Can you see it? It looks like that it's about x equals -2. Well, it touches, okay? So it touches, and they tell me it touches the x-axis. And before, if it touches the x-axis, it has an even multiplicity. And yes, you need to still know this, okay? This concept. Now, and then I see another one over here. Can you see it? Over here. And if I have to count, it looks like it's about 5, okay? So in another one, it's about 5. And it crosses the x-axis. So I know it has to be an odd multiplicity, all right? So those are the x-intercept. Then I'm gonna need to know, hey, do we have any y-intercept? There isn't any. And then I need to know the VAs. And VA, looks like I have 2 VAs, and it's already labeled for us, so this one is nice and simple. They are at x equals -5, okay? And now, this is super important, okay? Check out this VA, which I'm gonna highlight. See this VA? Right there, okay. This particular VA, x equals -5, I have 2 things, and now I'm going to use a different color pen. One curve that's going up and one curve that's approaching this VA is going down, okay? Because I have 2 curves approaching the same VA and they are going opposite direction, okay? So opposite directions. This tells me I'm going to have an odd multiplicity, and yes, VAs also have even and odd multiplicity because VAs are the zeros of the denominator as well as the x-intercept is the zeros of the numerator. So yes, they're in essence almost the same, except one is the zeros for the numerator and one's the zeros for the denominator. Then I have another VA, which I'm gonna highlight. How about green? Right here, okay? So that VA right there is at x equals to +2. Now, if we look at this is amazing, right? So look at the 2 curves that's approaching x equals to 2. They are both heading down the same direction. Okay, they're both heading down the same direction. So the same direction means we're going to have an even multiplicity. Okay, so I need to know even and odd because then I need to figure out what degree to give each factor. Now, oh wait, do I have a y-intercept? I do, huh? my bad, y-intercept. All right, where is this at? Does it look like it's crossing? Okay, let's zoom in really quickly. It looks like it's crossing at -2. What do you think? Okay, yeah, looks like that's about what I wanted to. Okay, so it looks like x is 0 and y is -2, or we can write it as a 0, comma, -2. Okay, all right. Okay, so we have a y-intercept there. Now what else do I need? I also need to have HA. I have one HA, and it's already labeled for us, so that's really nice. Y equals 2, so that right there. Okay, so now we are going to put it together. Here we go. Rational function it is. R of x, it's going to be some a value. Okay, again, we're still going to have a value. And because I have two x-intercept, I'm going to create two sets of parentheses. I'm going to have to create two parentheses for the denominator because I have two VAs. And again, I'm just going to start with x minus, x minus, x minus, and x minus, okay? So the first x-intercept, it's at -2. So I'm going to put in -2 in there. Okay, I will change that to positive later. And the second one is going to be +5, so x minus 5. And I will come back and do the even multiplicity and odd multiplicity later. The second one I'm going to take here is the VA. It says -5 here. Okay. And the next one is +2, so I'm going to put +2 right there. So the next I've taken care of the x-intercept, I've taken care of the VAs, okay? Now for me to have an HA, so this is important right here. For me to have an HA of a constant value, the degree on the top and the degree on the bottom must be identical. So at x equals to -2, it says I should have an even multiplicity. I'm always going to give myself the smallest even multiplicity, which is 2. And at x equals to 5, it says I should have an odd multiplicity. I'm going to give myself a 1, which in theory I can write a 1, but I don't need to, so I'm just going to erase, okay? Now on the bottom with the VAs, it says when x equals to -5, I should give myself an odd multiplicity. So again, in theory, I can give myself a 1 power. And at x equals to +2 on the VA, I can give myself an even multiplicity. But again, I'm just going to go back and erase this 1 power because you don't really need to, okay? So if you look at this, the degree on the top is now 3 and the degree on the bottom is 3. So yes, it will give us a constant. Now, what constant is really depending on this? Can you see this right here? I have an HA at 2. Right now, let's say that A, it's unknown. Well, how do I get this entire rational function to give me an HA of equals to 2? Well, you can do this. Well, currently, think about it. If I'm going to erase, and you don't have to do anything or write anything right now, if I'm going to erase the A, okay, what do you think the HA is? Right, the end behavior on the top is simply x to the third, right? End behavior on the top is x to the third. The end behavior is x to the third as well. Well, if I were to reduce, that would give me a horizontal asymptote at 1. But I don't need a horizontal asymptote at 1. I need it to be 2 according to the provided graph. So what A needs to be, so let's put A back, okay? What A needs to be is good. It needs to be 2, okay? So we're going to plug it in. And don't forget, we also have to check, okay? A equals to 2 times the quantity of x. I'm going to simplify the plus right here. X plus 2 squared times the quantity of x minus 5 all over quantity of x plus 5 times the quantity of x minus 2 squared. Well, I have to check. Okay? The reason I have to check is because I also need a y value at -2, a y-intercept at -2. So I'm going to plug in 0 for x to see if this is correct, okay? So y equals, when x is 0, this is 2 squared, and this is going to be -5 all over. Moving up so you can see. This is going to be 5 in the bottom and then -2 squared. So let's see if I'm going to end up with a y value at -2. So y equals, that's going to be 2 squared is 4, 4 times 2 is 8, 8 times -5 is -40. And from history, as you know, yesterday I divided incorrectly, so hopefully I'm not going to make the same mistake today. So -2 squared is 4, 4 times 5 is 20. I need to reduce, and it does give me a -2. Check and check, okay? What that means is this equation is good. And no, you don't have to multiply it out, okay? Save us some time. So let's recap a little bit because this is super important, okay? We know already from the polynomial concept that touches means even multiplicity. Crosses means odd multiplicity. Now the same concept has to apply in vertical asymptotes. Opposite directions, odd multiplicity. Same direction of the curves, even multiplicity. And you have to assign those to your factors, okay? All right, so with that said, I'm going to continue to our next example. Are you ready? Let me just make sure it's straightened out, okay? Give me a second, please. Okay, so here we go. I just need to move things up a little bit. This is my third time using this new app, so I'm not 100% sure how to do everything yet. So just be patient with me, please. Don't be mad, okay? All right, here we go. Let's read this really quickly. Example 3. Reynolds Metal Company manufactures aluminum cans in the shape of a cylinder with a capacity of 500 cubic meters. I'm sorry, not meters, but centimeters, which is AKA half a liter. The top and bottom of the can are made of some special aluminum alloy that costs about 0.05 cents per square centimeter. So that's not 5 cents, okay? It's 0.05 cents per square centimeter. The sides of the can are made of material that costs 0.02 cents per square centimeter. Expressed, this is the letter A, the cost of material for the can as a function of the radius r of the can. Okay, so now you have to understand. It says here, express the cost. I mean, in the end, I need to know the function in terms of cost, okay, with respect to radius of the material. Well, material in mathematics, it's just the surface area of the can. So we are going to do A and using math. Here we go. So cost, okay, that means I need the cost of top. Would you agree? Also, I need the cost of the bottom, okay, and I need the cost of the sides, okay. Well, these are all surface area, okay? So that means I need the surface area of top plus bottom, because they're both circles, okay? And then the sides, which is really the rectangle. So how do I find the area of the top and bottom? So area equals, I have two circles, plus a rectangle, okay? And then we're going to calculate the cost in just a little bit. So area equals, here we go, two circles, area of a circle is provided for us. It's pi r squared, but I have two of those, so I'm going to multiply by 2. And the surface area, it's normally length times width, okay? But I'm gonna kind of break this down for us. Here is the width, which is really the height of the can, which is defined it over here, okay? So keep that in mind. So I'm gonna go in and put in, I'm gonna just kind of write this over really quickly and then break down. The width is the height of the can, okay? Times that to the length. Here's the length. But this length is really the circumference, okay? This length is really the circumference of the circle that got flattened out. And the circumference, okay, of a circle is really 2 pi r. So this length right here, because it's a circumference, is really 2 pi r. So instead of writing length, I need to write 2 pi r, okay? And if you just know, and if you remember the formula from geometry, I'm perfectly okay with that as well. So when I simplify this out, I should have 2 pi r squared plus 2 pi r h. This is just the surface area of the can. Now I need to factor in the cost, okay? So here we go. Now I'm working with cost. Cost for the top, which are the two circles, 2 pi r squared, is going to be, according to your problem, is going to be 0.05, okay, cent for the top. Now on the sides, it looks like it's slightly cheaper, so 2 pi r h and times it to 0.02 cents. Well, that is the cost equation, but it doesn't want cost in both r and h variable, because notice right here, I have variables r and I have variable r and h, and it only wants a cost according to this in the radius, okay? So I need to get rid of h, substitute h. And how do I do that? Well, you are given a volume. See this right here? Oops, I shouldn't cross it out, my bad. Let me erase. I meant to highlight it, okay? It's giving you a volume of 500 cubic centimeters. What that means is volume equals 500 centimeter cube. Well, the volume formula is pi r squared h, okay? And I'm just going to take it and set it go to 500. And from here, I'm going to solve for h. So here we go. I'm going to divide both sides by pi r squared. So h equals 500 divided by, let's move it up a little bit. Okay, so that's h. And what am I going to do with this? I'm going to substitute this back to this right here, back into here, okay? So now let's write our final equation. Cost in terms of r, or c in terms of r, is pi r squared, 2 pi r squared times 0.05. You know what, let me simplify that out, okay? I don't want to write 2 times, okay. So 2 times 0.05, it's actually 0.10, okay? Pi r squared. Then I'm going to add 2 pi r. H is no longer h. I need to substitute h with 500 over pi r squared. And I still have the 0.02 here at the end. Woo, oops. Give me a second, please. Let me just maximize this thing really quickly. There you go. 0.02 here at the end. Trying to squeeze that in. Whoa, there you go. Okay. So now let's just write cost in terms of r is 0.10 pi r squared. Let's move it up a little bit so we can see. I'm going to simplify carefully. Here we go. Pi with pi, and an r here, and there's an r squared, so I have one r left, and I'm just going to multiply out 0.02 times 2, okay, and then times 500 here. So all of that, when I multiply them together, it's going to become 20. And then since I have an r left on the bottom, it's going to be 20 divided by r. So this is the cost in terms of r. R is the radius of the can. So the bigger the radius, I think, the more cost is going to be more cost to make. Okay, so now that we have A done, let me just scoot back down to see what the next letter is. All right, B, use a graphing utility to graph the function C equals C of R. Now this is the part that I'm going to ask you to do on your own. Okay, so once you have it done on your calculator, I would like for you to draw this over here, sketch it out. The x-axis is going to be your radius. Okay, the y-axis is going to be your cost. I would like for you to find at least 3 or 4 points on the graphing calculator and then do a little sketch on that for me. The next letter, let's scoot down here a little bit, okay? What value of R will result in the least cost, okay? Once you have it on your calculator already, I would like for you to continue this in now that you have it on your calculator. Go ahead and try to find the least cost. So the least cost is when, because it says what value of R, okay, so I'm looking for R. The least cost is when the radius is, and then fill that in for me. And then a unit of measurement is centimeters. Okay. Once you have an answer, do please check with your team. What value of R would result in the least cost? Okay, for this one, you shouldn't have to do any more work. Okay, so it's here. I'm sorry, that was C already. What value of R will result in the least cost is C. What is the least cost? D is the same thing as C. Now you just have to tell me the cost, okay? The least cost is, and then this is going to be a dollar amount or penny depending on how you're writing it to make sure you use the correct unit of measurement. Okay. And once you have an answer, please do turn to your teammates and compare answers. Most likely you will see this problem again on your very next exam, so make sure you are trying to work this out, especially the calculator part of it, because I know not all of us are very comfortable using the calculator still. Okay, all right guys, this is the end of our notes. Have a wonderful day.